because for today, we're just going to dig into the asymptotes more. We talked about holes yesterday, and we talked about domain yesterday. We didn't really talk much about asymptotes. So let's just review yesterday's stuff. Can you tell me what the domain of this thing is? In the old days, I would say a domain is from left to right, which is still true, but now it's a little more like what's allowed and what's not. I like to say that domain is what you can safely feed the function. You can feed it any x except, so that you could put all reals, except x cannot be. And I know some of you are like, but didn't you say to use this? Yes, this also is true. It works from negative infinity all the way to positive infinity, but it stops working along the way at -2. So x cannot be -2. Does that make sense for you so far? All right. Any questions? Okay. Do you get that this graph here that's doing this pattern is a y equals 1 over x graph at heart? But it's been moved over, it's been moved to the left, it's been moved up, and it's been flipped. This is important to remember. The normal one looks like this. Process that for a second. Do you get this one's been flipped? Reflected? Because it's actually over like this. It's more like the blue ones. All right, so it was a normal one of these graphs, but it got transformed. All right. Now this hole right there is right above the 5. And that means to me that somewhere in the function there had to be an x minus 5 and an x minus 5 like this that factored out. That's what makes a hole. Do you remember that part? That's what makes the hole. Okay, good enough on the review part. So let's go to this. If you didn't notice this, -1 was a problem yesterday, right? You can't let it be -1. And either it was a hole or it was an asymptote. If it didn't work, it was either a hole or an asymptote. And there was some like this where you'd have like x plus 1 over x plus 1. That kind, you'd have a hole at -1. If it didn't cancel, like in this kind, then it's a vertical asymptote at x equals -1. Now, x equals lines look like this, vertical asymptote. Okay, so how do you get your vertical asymptotes? They're what makes the bottom 0, but is not a hole. All right, so I'm going to give you another one that's similar to that. See, this one's going to have a hole and an asymptote. Please go off to the side, write this. Y equals x plus 7 over x plus 7, which clearly is making a hole, and x minus 5 on the bottom. You can feed this function anything you want, except for two things. It can't be, x cannot be -7. So all real numbers except x cannot be -7 and x cannot be 5. One of them's a hole. One of them's what? Don't just say asymptote. Vertical asymptote. Would you please label this one as a hole? And where is the hole? -7 comma what? Don't just assume 0. No, don't just assume 0. Negative hole comma something. Or sorry, -7 comma something. And this one's the vertical asymptote. And you should know how to write that. We just talked about how to write vertical lines. And never just say 5. You're in too high a level of a math class for the answer to just be 5. Vertical asymptotes are a line. Did you know it was x equals 5 is the vertical asymptote line? Okay, good. then how do I get the other part of the hole? You stick the -7 into the equation. Well, don't put it in here, though. Then it would just make 0 over 0, and that's not going to help anything. So get rid of that. That cancels and reduces to just 1 over 1. And then stick the -7 in here. So y equals, that's what I want, right? I want the y. Y equals 1 over -12. Raise your hand if you had that one right. Okay, good. That's how you find holes and vertical asymptotes. The holes look like this. They cancel stuff. The vertical asymptotes, they're the other things that make the bottom 0. All right. Let's go to this page. Would you please take a second, and of course, if you can factor it, you should. And then, would you please find where the hole is, where the vertical asymptote is, and write the domain of this, and don't even graph it yet, but know that down the road, that's coming. I'll pause while you give this one a shot. Okay, by now, the factoring just has to be like second nature. I bet you anything there's an x plus 3 in this, so I'm even just starting with an x plus 3. And then I'm going to go, it must be x minus 4 to go with that. See why I could kind of assume that? Because they probably want me to cancel that. I can't just be sure that that's the case, but I thought it was probably right, and I'm double checking it. And that worked, yay. That cancels that. Don't leave it as nothing on top. 1 over x minus 4 is the resulting function. Now, just side note, if you did have to graph it, that's what you would graph. Y equals 1 over x minus 4. That's what you would graph. But you need to remember there was a hole that was created back there at -3 comma something. -3 comma what? You put the -3 in this resulting function. And you'd have y equals, so this part is y, equals 1 over -7. -1/7. Where is that? I'm going to show you. -3, kind of better erase this area here. Right about there. There's a hole. Okay. It'd be nice to have written the domain. I usually did the parentheses kind, but I'm going to start doing this kind. They're both okay. And this part factored to x plus 3 and x minus 4. I need that again so I can see what the things are that aren't allowed. X cannot be -3, and x cannot be -4. Okay. And one of those is a hole, that one. And the other one is an asymptote at -4.
Wouldn't it be 4? Yeah.
Oh, +4. Thank you. Thank you. That's a +4, not a -4. Sorry about that. Fix that. There we go. +4 asymptote. Okay. 1, 2, 3, 4. All right. That is not much of a graph. I got one empty spot where the graph technically goes through there but isn't there. And then I got this asymptote line. I don't know where anything else is. If I had to graph it, you're just going to make an XY chart and find a bunch of points. I don't need you to do that right now because today's not all about the graphs. But if you did, you'd just go like, well, I think 4 is a good thing to stick in and realize, ooh, it's the asymptote. Then anything around 4 will work. Like 3 works pretty well. Stick it in, and you see 3 minus 4 is -1. 1 over -1 is -1. And 5 would work, and it turns out to 1. And then you get a few more points, and pretty soon you start realizing, boy, it'd be nice if I had the vertical and the horizontal asymptote. I can see where the horizontal asymptote is. Just based on where all those points are, things like to go near the asymptote. And you see this one, how it got really close to 0, but it didn't touch 0? That's where I think the asymptote is. So maybe I should teach you next how to find the horizontal asymptotes. Because if you got the horizontal asymptotes in there and the vertical asymptotes, then you just got to finish your lines because you know they get closer and closer to the asymptotes. This would be the graph. It has to go through that hole and keep going. I know that's what the graph looks like. So how do you find this line right here at 0? How do you find the horizontal asymptotes? All right. Please get to this one. We'll talk on this new one about how to find the horizontal asymptotes. All right. For a vertical asymptote, I'd need to know first whether or not that 2, the 2 is going to be a problem, right? It's either a a vertical asymptote, or it's going to be a hole. Leo, what do you think? Is it a hole? It is. Because on top, you'd factor this to x plus 2 and x minus 2. And that means, oh yeah, look at that. Those cancel. That's definitely a hole. So this one does not have a vertical asymptote. Okay. Now, how do you figure out the horizontal asymptotes? All right. First of all, not everything has a horizontal asymptote. Like if I just said, here's the graph of y equals x. You guys remember y equals x? It's the line that just like goes with 1, 1, and 2, 2, and 3, 3, and 4, 4, and it goes this way too. And does that look like it has any asymptotes? No. So the point is not everything has horizontal or vertical asymptotes. All right. So usually it'll be a fraction function like x over x plus 4. That's a fraction function. That one has what kind of an asymptote? Does that one have a vertical or a horizontal asymptote? That one has a vertical asymptote. Maybe you're not ready for this yet. Do you get that that is not a hole? Because there's nothing to cancel it up above. And so if it's not a hole, it must be a vertical asymptote. This kind's the vertical asymptote. All right, so the vertical asymptote for this one was at x equals negative 4. So how do you find the horizontal asymptotes? All right, obviously this graph went with just y equals x, so I'm erasing it. Now here's how you'd find the vertical asymptote. Well, you just look on the bottom. As long as that's not a hole, x equals negative 4 is the vertical asymptote. Would you please put this on the side of your paper right now? Copy this problem. Copy this problem. Write down vertical asymptote, and then I'm going to show you how to find the horizontal. And the horizontal asymptotes are related to something called a limit. You are going to learn limits for like a month in calculus. But you aren't even in pre-calculus yet. Limits are a big deal, and I get to talk about them today for the first time. All right. So a limit is like what eventually will happen to something. Okay, so do you get when they first came out with flat screen TVs? Do you get that maybe you weren't even around, but they were really expensive. For a flat screen TV, it was like thousands and thousands of dollars. But now on Black Friday sales, you can get like a flat screen, fairly big TV for like 150 bucks. So the limit in the long run, if you talk about flat screen TVs started out really expensive and they came down. Are they going to go to $0? No, they'll level off somewhere. But the price of seriously, it was like $8,000 at the beginning to get the same kind, in fact, not even as good as today's flat screen TVs that are like $800 or less. So they've come way down in price. So in the limit is like saying, if I keep going forever, what's it going to level off at? Because that would be like a horizontal asymptote. See what I mean? All right. I'm going to use the example of electric cars. I love my electric car, but it was expensive when I bought it. And it's come down, and if I would have waited, it'd be cheaper. Do you think it's going to get even cheaper? Yes, electric cars are going to get cheaper and cheaper and cheaper. Will they go to $0 for an electric car? Of course not. But they will get cheaper and cheaper and cheaper, and they'll level off somewhere. And right now, we're like here. Electric cars have already come down a lot, but they're going to go down a lot more. And eventually, what's the limit? Where will they stop? My theory is they'll get to be like $18,000, which is really cheap for a car. Like the cheapest cars now are actually like $20,000 for gas cars for a new one. I'm talking a new car. I think electric cars will eventually be this cheap. Eventually. And they'll be nicer than the car that I bought. Because new technology gets better and better, right? Okay, so moral of the story, in the limit is like in the long run. Okay. So here we are in 2024. Out in the year 2050, like way, way, way out in the future, it'll be way cheaper for electric cars. So they'll just get cheaper, cheaper, cheaper because it's easier to manufacture them. Just like flat screen TVs. Why should they be so cheap? Because they got easy to manufacture. Everybody knows how to make them. They got used to it. They got good systems for making them, and flat screen TVs are cheap now. All right, so that's called in the limit, is in the long run. Do you get limit goes with the long run? Okay. So we're trying to find horizontal asymptotes, which is like lines like this. All right. So if we go back to this problem, in the long run is like a long time from now. This one is the one we were doing. In the long run, if I put in a big number for x, and I find the nice number for that to me is 1,000. If I put in 1,000, that's like way over there, right? Like it's in the long run. I put in 1,000. Do you agree that 1,000 there and 1,000 there? I know math is usually picky, but do you get it at 1,004 is pretty darn close to 1,000? So would you agree that 1,000 over 1,004 is pretty much 1? 1,000 over 1,004? Isn't that pretty much like 1,000 over 1,000? Which is pretty much 1? Then that's what the limit is, and so that's what the horizontal asymptote is. Y equals 1. In the long run, what's it going to go to? 1,000 over 1,004. Y equals 1,000 over 1,000 about. 1,000 over 1,000 is 1. Y equals 1. Yes, you're rounding. We don't always have to be super accurate in math. We're saying it's about 1. All right, here's another one. Oh, wait, I should put that in down here. My horizontal asymptote was y equals 1. I put in 1,000, and I see what it goes to. Because in the long run, is like x is 1,000. X is usually time in real world problems, and a time is 1,000 will be like 1,000 years from now. I think 1,000 years from now, there's going to be robots everywhere. Heck, I think in 50 years from now, there's going to be robots everywhere. Not like killing you, like you did immediately. I think that they're going to be super helpful. Like, 50 years from now, when you're like my age, man, there's going to be tons of robots. They'll be really cheap because in the limit, in the long run, they're not even near as big as a car. They're about 1/10, no, probably 1/30th the size of a car. So it'll be fairly cheap to make them, and they'll do a lot of really good work. Like, sweet, I could have a robot just taking care of my house all the time, just constantly going around washing the windows and vacuuming the floor. All right, so in the limit, in the long run, you put in 1,000. All right, here's another problem. Let's see if you caught that. Y equals 2x over x plus 1. Let's see what the long run of this looks like. So what we're trying to do is find a horizontal asymptote, which is y equals something, and we got to see what it's going to be in the long run. What number did I say was good? 1,000. Do you get that that is a made-up number? You could put in 1,000,000. You could just put in 20, but it doesn't show up as well if you put in a smaller number. So in the long run, put in 1,000. What happens here? 2 times 1,000 over 1,000 plus 1. Do you remember how I said it's kind of like you're rounding? So do you agree 1,000 plus 1 is pretty much 1,000? So you can just kind of ignore that. But timesing something by 2, doubling something, now I pay attention to that. If you had some money in the bank and I said, poof, I just doubled it, you'd be like, oh, that matters. Like, I like you doubled my money. So doubling, it matters. 2,000 over 1,000 pretty much rounds to 2. So y equals 2. That's the horizontal asymptote. Pretty much is, notice I rounded, and it's okay to round. It's pretty much 2. Y equals 2. So if you were to graph this, that's saying that this graph would eventually get really close to that line at 2. Maybe the graph looks like this, and it was getting closer and closer and bigger. Or maybe the graph was getting smaller and smaller and getting closer to 2. But either way, it's getting closer to 2 in the long run. All right, here's another one. Y equals 5x plus 4 over x plus 17. You'll get good at these after a while. And when you're in calculus, that would have been, what's the limit of this? And you'll be able to just look at it and go, ah, that's easy, it's 5. But for now, I'm going to call it the 1,000 trick. In the long run, that's pretty much 1,000. I know 17 is something, but it's really nothing compared to 5,000, right? And plus 4 doesn't really do anything. Now, does the thousands do something? Well, yeah. And 1,000 over 1,000 can actually just cancel. And I got y equals 5. Raise your hand if you had y equals 5. Awesome. Now that's how to find the horizontal asymptotes. Okay. So it's like in the long run, where will this function go to? And it's going to go towards 5. If the graph was here, y equals 5 is kind of like where it's going to end up. And again, I don't know whether it's going to get closer and closer from this side to 5 or whether the graph is coming down to 5, but it's going to be near 5. Okay. So let's see if you really got this, because if you do, we're pretty much done for today. You ready? Y equals 2x over x minus 12. I'd like to know what the vertical asymptote is, the horizontal asymptote. Oh, and wait, I'm going to throw in one more thing. X minus 3 and another x minus 3 on the bottom. Correct. I needed there to be a hole. Okay, so vertical asymptote, horizontal asymptote, and the hole is where? That's my question. Because once you get this on the graph and you're like, oh, here's my vertical, here's my horizontal, and here's the hole, you only need a couple more points and you got the graph done too. It's like really close. If you get the horizontal and the vertical asymptotes and a hole on the graph, you're pretty much done graphing. All right, so please find the horizontals, verticals, and the holes. And remember, your answers are never just 2. It's got to be like x equals 2 or y equals 2. And if you get confused by them, I understand. But I'm going to say a dumb way. The vertical asymptote, get what I did there? The vertical asymptote starts with x. See, x and vertical, kind of put them together. And the horizontal asymptote, horizontal, why? Horizontal, see what I did? That'll keep you straight on which one's which. All right, please compare these two answers to the kid sitting next to you. Maybe not the hole yet, that's going to take a bit. Just figure out the vertical and the horizontal. And can you cancel these off? You absolutely should. Just remember that they made a hole. All right, please, if you haven't already, talk to the kid next to you.
I think so. I goes to -3 on the bottom. Gives you -9. 6 on the top.
This is what I got.
-34. Well, it's 6 over. Negative.
Wait, so you have this stuff.
6 negative. Oh, it's 9.
Oh, the vertical? Yes. Because if it's x minus 3, oh wait, hold on. 3 minus 2 is negative 4. Oh yeah, I forgot what this is. But yeah, so it's negative.
Okay. There were two things that would kill this function. One of them was 3, and it kills the function via being a hole in the function. And that 3 goes in here and here, and it makes 6 over 9. Would you agree that, oh wait, -9. 6 over -9 makes -2/3, I think. Raise your hand if you had -2/3. Nice. And then the y is the horizontal asymptote. Ooh, that's the 1,000 trick. I'm going to see, like, in the long run, what it equals. So I'm going to put in 1,000. That's 2,000 over pretty much 1,000. So 2,000 over pretty much 1,000 simplifies to 2. So y equals 2. Raise your hand if you had that one right. And lastly, the x equals thing is x equals 12. Does that make sense to you? All right, cool. Now what if you had to graph it? Well, you'd already have the x equals line. It would look like this. You'd have the y equals line. It would look like this. There'd be a hole at 3 comma -2/3 over 3 and down 2/3. Like there's a hole like that. Now I'd need more points, but do you get if I find a bunch of points and they're like this, you're going to go, oh, well, I can see where the line goes. It goes right through that hole. And then let's say there's another point up here. You'd be able to figure out, it's going to get closer and closer to the asymptote. So if there's a hole here, then it must run like this and this. That's the last thing I have to teach you is just graphing a bunch of points, which is easy. You've found points since the first unit. How would I find points in this? You'd take this, you'd stick in things like 0 and see what you get. Stick in 2 and see what you get. All right. Move to this page, please. If you had to do this, would you agree you'd have to factor that? Would you agree it probably has an x plus 3 in it, which makes a hole? What if it doesn't have an x plus 3 in it? Then it's not a hole. It's a what? It's a vertical asymptote. If you can factor it, you should, and it would also be easier to find the horizontal asymptotes because you put in 1,000. And can you imagine putting 1,000 in this? Isn't that going to be a big pain in the butt? But if you factor it first, it's easy to put in 1,000. All right, go to this. Go to this. Let's definitely practice this because this is, we haven't even done any like this, and this is on today's homework. Okay. Now, so far I just gave you equations. Now all of a sudden you got a graph. Act like the hole isn't even there. What's the equation for this thing without the hole? Everybody start with that. Just tell me what's that equation? Think y-intercept, think slope. Remember how to write an equation for a line? Leo, what's the y-intercept?
-1.
Good. What's the slope? Colin? What's the slope? It is negative 1. It's going down 1 and over 1, down 1 over 1, down 1 over 1. Okay, so it's negative 1x. There it is. Negative 1x minus 1. Do you get how to write an equation for a line? But this one has a hole in it. So all you have to do is, you know what holes look like? They're in fraction functions. First, put parentheses around this. I'm warning you. Those implied parentheses are important because you're about to put a hole in and it's going to look like that. And you need those black parentheses in there first. Okay, now the hole is at negative 4. Remember, the x part is the what you do first, right? So what's got to be in the parentheses? X plus 4. Because do you get that negative 4 will make that 0 and therefore cause a hole there? Okay. That's how you write the equation. You act like there is no hole. You write the equation for that. And then you go stick the hole in. All right. Go to this one. Act like there is no hole there. What's the equation for that kind? 1 over x. And now there is a hole there. So, do. Fanning, what do you think this is at right there? 3. So what do you think goes here?
X minus 3.
Yes, nice. There you go. That's the equation for that graph. You start without the hole, then you just put the hole in at the end. All right, I feel like you're getting this. And the good news is that tomorrow is, I've already taught you all of tomorrow's stuff. Because tomorrow's about horizontal asymptotes, and it's not even on this assignment. So I'll start with a couple reminders, but then you'll have a whole bunch of work done tomorrow. Made our Friday easy. All right, so right now I'd like you to take out the homework. It's a worksheet, and there's usually a few too many problems on there. I'm going to pause while we take a look and see which ones to skip. Okay, so we're going to do the evens. Leo, please read me number 2.
F of x equals 4x over x plus 2.
And what do they want? Oh, wait, that's number 1. Boo, number 2. We're just doing evens, so number 2. Try again.
X plus 1 over parentheses x plus 3 parentheses x minus 2.
X minus what?
2.
Thank you. Okay, good. Now, what do they actually want to know, Leo?
Domain and vertical.
Okay, domain. I personally think you're ready to start writing them with big R, all reals, where x cannot be this and x cannot be that. Now, that other way is good too, and it just depends on which way they ask for on the test. If they ask for the kind with parentheses, that's called interval notation. So x cannot be negative 3 and x cannot be 2. All right. Mr. Y, can you tell me the next question?
You need to find the domain.
I did the domain. What's the next thing?
Vertical asymptotes.
Ah, vertical asymptotes. Vertical, zertical. I know it's x equals. X equals what? Well, the verticals come from down here. Were either one of them holes? No, there has been a lot of times, but this time there's nothing to cancel it on the top. So neither one of them is holes. Then they're both, what kind of asymptotes? Vertical asymptotes. They're both vertical asymptotes. X equals negative 3 and x equals 2. And don't you dare just write 2. That wouldn't mean anything. In the context of a two-dimensional graph, what the heck is 2? X equals 2 is a line on, x is a zertical one, vertical line. All right. And they don't even ask you for this, but I want you, so that you understand this for tomorrow, to write HA underneath it. And we're going to do the horizontal, which is in the long run, where does it go towards? So put in 1,000 Imagine you've put in 1,000. 1,001 is pretty much 1,000. 1,003 is pretty much 1,000. And 1,000 minus 2 is pretty much 1,000. But wait, it's 1,000 over 1,000. Would you agree that I can cancel those 1,000s then? And I only have one 1,000 left on the bottom. But wait a minute, what the heck is 1,000 on the bottom? Well, really, there's a 1 on the top, because when you cancel things, you're relieving a 1 behind. It's 1/1,000th. If we're kind of rounding, what is 1/1,000th really close to? 0. The horizontal, I said it was the horizontal. And do you get why 1/1,000th is not 1,000 at all? 1/1,000th is pretty much 0. So the answer is y equals 0. There's an asymptote at 0. These won't ever is a big word. Almost never come out to a perfect number. You got to kind of round them. You got to think. And 1/1,000th, that's pretty much 0. Okay. All right. Again, that's not officially on today's homework, but we're going to do the evens. So let's go to number 4. Frank, would you read me number 4, please?
Lies over x times x plus 2.
All right. They probably want the domain again. You always start with all reals, except x cannot be 0, and x cannot be -2. Good. Because neither one of those were holes. And there's usually only one other thing. If besides holes, they usually want to know the verticals. Is that what they want? And remember, if these things are either holes or they're verticals. In this case, it's verticals. So the vertical asymptote vertical x equals 0 and x equals -2. That's with the lines that the function can't be. So if you were to graph this, I'm just making sure you really get what this is. That's saying the function would never touch -2 and the function would never touch 0. They can have 2 of those kind of asymptotes. And then it can do all kinds of crazy things. If we actually had to graph this, sometimes it looks like a x to the 3rd graph. Sometimes it looks like this. Sometimes it looks like this. There's a lot of different things where the graph could be. All we have right now is where the graph can't be. It's the asymptote lines. Okay. Just kind of getting you ready for the rest of the unit, which is graphing them and finding the horizontals. And in just a few days, we're going to be done with everything. And from there, it'll just be taking one more test on these rationals, and then the cumulative, and then the final. So, all right. Okay, that was number 4. You keep on doing the evens. Now, this is not a law. It's not like you can't do the odds. Like if you struggle with one of the evens and you're like, crap, I got it wrong. I looked at the key and I got it wrong. It'd be very smart to go do the odd one then to practice, because if you don't get a kind, there's another one for you that's a lot like it in the odds. All right, that's all I got for you for today.